Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I'll be calculating the values for a resistive, inductive series complex circuit from the Chapter 16 math handout, problem number 21. We see here on the screen how we need to set our notebook up in order to calculate the problems number 17 through 24 from the Chapter 16 math handout. So I would draw a line about halfway down my paper. I would leave some space to draw out my circuit. I would label my values by my circuit. Remember that you do have to memorize this spreadsheet down here. The electrical quantities value sheet must be memorized. So you got to memorize that you have a VT, a VL, a VR, an IT, IL, IR, ZT, XL, R, and theta Z. So here we see how I've got the problem laid out on my paper. I will be taking my known values from the Chapter 16 math handout. As you see here, I have highlighted problem number 1, 50 volts, an XL of 30 ohms, and an R of 40 ohms. And I will be using the formulas from the Chapter 16 formula sheet that you see here, and the formulas that you use for the series complex circuit is 17, 18, 19, and 20. And make sure that you stick to only 17, 18, 19, and 20 for the series circuit. Meaning don't use any of the 21, 22, 23, and 24 calculations for your circuit here. I will put a link to both of these documents in the video description below. You see here that I've clipped the formulas that we will need from the formula sheet and put it on our page. So let's begin with our calculations. We see that our steps tell us that the first thing that we're going to calculate is ZT. So we look at formula number 19, and ZT is equal to the square root of R squared plus XL squared. So the first thing I'm going to do is open square root. So if you look at the calculator, I'm going to hit this button right here. That opens the square root. Then I'm going to put in the R value of 40 ohms, and I'm going to square it. Here's the squared button right next to the square root button. So it's going to be 40 squared plus the XL, and XL stands for inductive reactance. It is a type of opposition to current flow, just like resistance is opposition to current flow, but it's a type of resistance to current flow that only happens in AC with an inductor. When an inductor is in DC, he does not have inductive reactance. But once he is connected to an AC circuit, he will have a new type of opposition to current flow called inductive reactance. All right, so now I put my inductive reactance of 30 ohms in, and I square it. It equals, so my total opposition to current flow in this circuit, called impedance, is 50 ohms, and ZT stands for impedance. XL stands for not resistance but reactance, and of course R stands for resistance. So we were only dealing with resistance before, now we're dealing with resistance, reactance, and impedance. All right, so now that I've got ZT, I can find IT. I can use Ohm's law. Inside of these parentheses, I can use Ohm's law. So I've got 50 volts, I've got 50 ohms. If I put 50 over 50, that's going to give me 1 amp of current. Current stays the same in a series circuit, so I can fill in all of my current values. Now I use Ohm's law to find the amount of voltage dropped by the inductor. That's what VL stands for. The L stands for induction. That stands for our coil here. So how much voltage does my coil drop? Well, I take 1 amp times 30 ohms, and that would be 30 volts. How much voltage do I drop on my actual resistor? 1 amp times 40 ohms, you drop 40 volts. Now, you may ask yourself, well, 30 plus 40 is 70. That's not 50. What happened here? Well, if we look at formula number 17, we will realize that you cannot just add them up, because they go through the inductor and the resistor at a different time. The voltage goes through the inductor and the resistor at a different time, or we call that phase. They go through the components at a different phase. They're out of phase with one another. So you can't just add it up. To get VT, you have to do the square root of VR squared plus VL squared, because of the phase relationship of the voltage in those two components. All right, now that we've got all that done, the only thing left, we see our formula here for theta Z. That's the Greek letter theta right here. And we want theta Z, so it's equal to, watch my calculator, you have to do inverse tangent, so you have to hit shift first. You have to hit shift first, then tangent, and it's going to be XR goes on top, XL goes on top, XL goes on top, so that's 30 ohms, then hit over under, then you're going to put 40 ohms down below, you're going to scroll over, you're going to close parentheses, hit equals, and it's 36.87 degrees. This answer is in a degrees. On the test, you don't have to put degrees. You just have to put the numerical value. You don't have to figure out how to type degrees. All right, now that we've done all of our calculations, we see up here we were asked for VL, we were asked for ZT, and we were asked for theta Z. And these will be the three that you put into the Chapter 16 Canvas answer sheet assignment on your Canvas page under the Chapter 16 module. I hope this helps you. Again, I'm going to put a link to the Chapter 16 math handout and the Chapter 16 formula handout in the video description below. Thank you.